Continuous improvement comes in lots of different flavors and styles. I'm Bella Engelbach, and I'm inviting you to journey with me to the edges of lean. Episode 114, Designed for Six Sigma with Kris Stokes. When I say that there are many different flavors and styles of continuous improvement, Designed for Six Sigma is exactly the type of style and flavor variation I am thinking of. Product development is hard, it's expensive, and almost every company has a graveyard full of product development failures. Kris Stokes teaches organizations and people the principles of Design for Six Sigma, and he says that product development success takes rethinking many of our assumptions about what we know, how we know it, and most importantly, identifying our own hidden assumptions. He joined me at the Edges of Lean to share his knowledge with us. Dr. Kris Stokes, welcome to the Edges of Lean.
Thank you very much for having me. I'm excited to be here and happy to talk about Six Sigma processes.
Great. So, Kris, can you start out by telling us about yourself? Give us a little introduction to you, what you do, and how you got to do what you're doing.
So today I'm a principal scientist at Geisys Ventures. We do material science consulting. We do R&D management consulting to help people make their projects faster, better. We do extinguish fires for manufacturing when you're kind of at the end of your rope. We come in and take another look at it. And we also do product development work. I also have a soft spot in my heart for teaching. So one of the things I do because I love it is I teach Lean Six Sigma and Design for Six Sigma for Air Academy associates.
Oh, that's cool. That's great. So how did you come into this? What was your career path? Where did you start?
So that's a great question. I have a PhD in organic chemistry from MIT, and I will say that none of the lessons I've learned from, the Six Sigma practices, I learned in school, right? After graduate school, I went to a startup company, and I was still sort of doing things the hard way. We had an exit, which was nice, but I moved on from there to, from making molecules for oil and gas field chemicals to processing polymers for battery applications. I worked at a company called CellGuard, and that's where I was introduced first to Design for Six Sigma.
And so you came into it through DFSS first before sort of the manufacturing process type of Six Sigma. Interesting.
Yeah, absolutely. I had a boss that worked for Delphi, and he had gotten training in DFSS for Delphi at Delphi, and he brought in Air Academy, which is how I met these characters, to teach us how the DFSS process goes. And DFSS is, for listeners, is Design for Six Sigma.
Right. Wow. So that's fascinating to me because a lot of people, whether they are doing lean product development or Design for Six Sigma, they learn the manufacturing side first. They learn the how do I make it consistent, and effective and efficient on the manufacturing side, and then they come into product development. And product development is different, and sometimes people have a really hard time grasping that, right? That product development is really different. There are lots of times in product development that you need to have the type of repeatable, efficient, effective process that you need in manufacturing in order to accomplish product development. But that process from ideation through to putting a product on the market is not the same as running a plant. And so it's just to me, it's fascinating to meet people who started kind of at the other end of it. And I'd love to know, so what kind of insights, what were some of the things that grabbed you immediately when you started to learn about this?
So I will say the biggest thing that I took away, and the way that my boss implemented this is he started out with a sort of champions course where it was really getting upper management on the same level, and he very astutely recognized that I would sort of resonate with it very strongly.
Uh-huh.
So he brought me in as sort of like a mid-level champion as well, and we got a great demo of the catapult, right? Or as Air Academy likes to say, the statapult, where once you do the sort of designed experiment in a predictive way, and you can you do this thing where you shoot the ball at different angles and you record the values. It's purely empirical, right? And me coming from a place like MIT where it's you've got to build everything on first principles, coming to this empirical approach was really sort of striking to me at the power of it, because every time I've done sort of first principles things, the error bars are huge, right? Because the real world is,
The
believe it or
real
not,
world is,
messy.
it's not like a lab. Well, labs can be messy too, but it's not, it's even messier than a lab. Yeah.
Absolutely. And so, when I saw that just by doing a few experiments in a very methodical way, you could, number one, test a lot of variables at once. Number two, eliminate variables very effectively. And number three, see interaction effects, which end up being really the core part of these designed experiments, is these interaction effects that you can't really get in any other way. And the moment it clicked with me is when we put our predictive model in, and he said, all right, I want it at 100 inches. Tell me, or what was it? It was, you tell me where you're going to put it, and I'll put the cup here. Give me the 95% confidence interval, and I'm going to figure it out. You pull the lever back, the ball shoots out, and it lands in the cup like 95% of the time. And I can't express the excitement that I had and that my students have every time they see that, wow, I can kind of predict the future with a 95% certainty.
With you using designed experiments. Yeah. Yeah.
Absolutely.
But and I think that and I think that the thing that is hard about this for a lot of people is the idea of doing experiments at all, right? So as you said, the well, if we already know this information, or we think we know this information, or we think we can predict the future, then we're not going to do a lot of experiments. We're going to go ahead and design based on what we know. And for those of you who are listening, I'm doing air quotes, what we know, or what we think we know, or what we hope will happen. And then as you get further along in the product development process, you learn that you were not correct, right? And then that creates a huge amount of expense and rework, and sometimes, complete cancellation of projects because of those errors that are made, those thought errors that are made early in the process. So I'd be interested to know, Kris, when you're working with people, do you find that there are people for whom their own certainty gets in the way of being able to do this?
100%. One of the things that I also did is I moved on from being a student to being an integrator. I actually brought Air Academy in as the boss and trained my product development engineers, the manufacturing engineers, and I even brought in our marketing people, because the whole Design for Six Sigma process, it's actually follows, instead of DMAIC, it follows the IDOV process, where it's identify, design, optimize, and validate. I think there's actually another sort of acronym some people use that follows
DMADV.
DMAV. Yes, that's right.
Yes.
So I kind of like the IDOV approach because it actually it actually integrates into a lot of stage gate processes very effectively. So you can check off the boxes on, am I doing things properly in advance? But I had one employee who, after I did a designed experiment on one of our products, he goes, "Yeah, we already knew that." And I go, "Sure, but did you know that if you increase the temperature 5 degrees, you get twice the value? Or did you just know that you get more?" Right? So having that level of, where does the product fall off the cliff? Because they all do,
Mm-hmm.
right? You push it to the edge and then it falls off a cliff. How close to the edge can we get and make sure our customers can actually use it in their process?
And that's actually how you could drive a lot of cost out of your development process, right? Because if you know where those limits are,
Yep.
how thin you can take a material, or I don't know, depending on what you're doing in the pharmaceutical industry, it would be something like, what is the um stability, of a product, how far can
Absolutely.
you take the stability and allow and extend that shelf life, so that that a longer shelf life is better for customers. So, but you don't know until you've done the experiments, right?
You
If
don't.
and then that takes me to another question, Kris, which is about, what about documentation? Because I think this is the other thing that's really hard.
Mhm.
Is once you've learned something, we always say we say in lean, or I say in lean anyway. Once you learn something, it's wasteful to relearn it, right? Once you've done the right experiments, and they're good experiments, and you have the data, it's very wasteful to relearn it. But we do that over and over and over again. A lot of that is because we're not very good at documenting or sharing the information. I think it's getting harder, actually, with
Yeah.
all of the different places that we could store information. So how do you approach that?
That's a really great question. And I don't know that there's one good answer, because every organization has, as you mentioned, one of 1,000 ways of documenting things, even within SharePoint, right? I found that in our own usage of Teams and SharePoint and OneDrive, that they all get stored in different places, even though it's sort of in the cloud, in the same one cloud. But one of the most effective ways I've seen at sharing these things, because at the end of the day, DFSS is really focused on connecting your customer needs and their, what their desires are, their critical to customer requirements, to a transfer function, right? You want to be able to say, if I make this product with these properties, how does that map to providing value to the customer as they've defined it? And that's a whole other issue of, customers ask you what they want, not what they need. So sometimes that's the feedback loop, right? But if you are developing these sort of predictive mathematical equations, if you're good at it, you can say, hey, if I can give, for a glue, maybe, right? If I can give a peel value of X, then we know that's going to meet the customer demands. And how do we get to that? Oh, we have to turn the dials on the machine to, A, B, and C. Now, transferring that knowledge to manufacturing is where the documentation, I think, happens the best. And
Mm-hmm.
one of the best tools I've found is, when I was implementing this as a boss, I basically said, look, at the end of every project, you need to have a DFSS scorecard, right? And the scorecard is really a process capability. So it's made up of, the process, the performance, and the raw materials factors. So if I'm working with a plastic, right, I've got to know sort of, what's the performance of the product at the end. It's got, it has specifications on it, or it doesn't have specifications. It has a, you know, the variability around that, based on however you did that in the production or in the development process. The raw materials coming in, how does viscosity affect these things, right? What are the normal types of materials you see, and those material properties, and then, you know, what are your yields coming out?
That also takes, doesn't it, looking, when you talk about customer, you know, obviously we're talking about the person at the people at the end of the process who are going to use the product. But customer could also include manufacturing, right? You need to know something about manufacturing. Actually, I think a lot about manufacturing in order to be able to design something that is going to be easy to bring into a plant. So your tech transfer is not a nightmare, right? And if you need to build or qualify new equipment, that you've got plenty of advance notice to get
Yeah.
that done, because they have their own processes for
Yep.
getting that done, right? So does that mean that you say to folks who are working in research and development that they need to go and spend time in manufacturing? How do you handle that?
So I actively encourage people to, you know, make friends with the operators,
Uh-huh.
because the operators know the machines inside and out. You know, I often say that, you know, they've forgotten more than I'll ever know about the process. So it's really important to know the machine that you're working on, or know the process, and also to know the people, right? Because it's not just the process, or it's not just the machine that makes the variability. It's not just the materials that make the variability. I Every time I walk into a training session, we start talking about variability, and I go, all right, so let's talk about variability. Do you see variability between day shift and night shift? And everybody laughs every single time, because, you know, it's kind of the thing is night shift changes differently, because there's not, you know, there's a little bit different culture, you know, the
Fewer people, less management, maybe.
less management. It's just a different system altogether sometimes.
Yeah, yeah. So it sounds like the folks that you're working with usually know at least that much, right?
Yep, yep.
Yeah.
And so, you know, it's good to know sort of the historical, how does the process work, how does it, behave, and where are the pitfalls?
Yeah. Yeah. And what can you learn from those folks in the plant too? I think that's really important because, as you said, you know, they've forgotten more than sometimes the folks in development have even had a chance to learn. Um,
Yep,
and
absolutely. You know, I know that, there were times as a research scientist, in a former job, where there was an operator. His name was Reggie, and he, you know, I love this guy. He made me successful, because I would take my you know, run sheet for a trial, and I said, all right, Reggie, here's the deal. This is what I think is going to happen. How should I change this? And he's like, don't worry, Kris, I got you taken care of. Um, on the other hand, if, you know, I've seen, and I've coached and I've mentored engineers who don't sort of build that relationship with the operators, and it's very much a, all right, you put it down, this is what we're running. It doesn't matter if it turns out to be garbage or not. This is what it is. So at the end of the day, like everything else, it's about people and relationships,
mhm.
as much as it is about data.
Right, right. And it's also, I think, difficult sometimes in today's world. The plant may be on the other side of the world, right? It's not possible. You may not be able to walk across the parking lot and you know, go have a chat with somebody. You know, you have to get on a plane, and that's, you know, that's difficult and expensive
Absolutely.
and hard to do. So but that doesn't mean that you couldn't learn as much as you can, or at least attempt to learn as much as you can. Yeah.
Yep.
Yeah. So when can you take us through your acronym for Design for Six Sigma again and give us a little detail on each step?
Yep, absolutely. So um, the acronym that we use is IDOVE, which is I stands for identify. Now, identify is really getting the customer requirements. How strong does this have to be? How many do I have to have? What are the qualities? Really, what are the CTCs or CTQs, critical to customer or
Mm-hmm.
critical to quality properties of these particular widgets or process. And it's important to get this right and to have that have that relationship with the customer so that they can give you a little bit closer to what they need versus what they want. And so I've made the mistake of sort of not asking a deep enough question, and I deliver a product that meets all their specifications, and they go, this doesn't really work the way I want it to. Um, and it's because, I didn't ask that next question of, so what are you actually doing with this? They have a list. They think that they know what they want. But there's always these unspoken assumptions when they're communicating these needs to other people. They sort of automatically assume that what the substrates are that they're using, or what the intended temperature range is. But you have to ask these questions and drop you know drop the assumption that everything, right? You
Right,
know
right. Yeah,
nothing.
it's what we were talking about before. It's certainty that causes a lot of problems. That yeah. And so again, does that call for, spending time with the customer? I think, certainly there's this idea, well, I'll bring the customer in, we'll sit at a conference table, we'll talk about the thing. But that's really different from what, in Lean, we'd say, like, go to the actual place, go to the Gemba, go and actually, watch what the customer's doing, spend time with customers. Um,
Yep.
so you could start to get those. But isn't that also a place where you could actually start experimentation, Kris, where you could start with, web developers do, try this version versus this version. How does this work for you? Which
Yeah.
is yeah.
Yeah, I
Do you
mean,
do that?
you can absolutely. I think it's good to sort of target in a little bit early. Be like, all right, I'm not sure if this is the solution or this is the solution. You kind of do a little A/B test if you've got the relationship, and if it doesn't cost them too much to
Right.
do.
Yeah.
I've worked in the battery industry before, and like a full set of testing is sometimes 18 months and hundreds of thousands of dollars. So it's not as easy to do some of those tests as it is, hey, give me your fabrics, I'm going to bond a couple of them up together and we'll see how it goes.
We'll see how it works. But yeah, but you're still when you're doing that, you're still getting something that's real about what they're doing, as opposed to imagining with our own personal certainty about
Exactly.
what they're doing. All right. So that's identify. What comes next?
Next is design, right? So the idea there is you start using things like, tools like House of Quality, right? To
Mm-hmm.
map what the CTCs or CTQs, the critical to customer properties are. So if I say, I want, I'm trying to find, I want this to be, white. I want it to be light. I want it to, have a long battery life. What
He's
are those
holding, for those
actual?
of you who are listening, he's holding up an Apple
Oh,
mouse.
yeah. Sorry,
Yeah.
I'm holding up an Apple mouse. Thank you for the
Yeah.
reminder.
Yeah.
But and at the end of the day, like, the unspoken thing that I didn't
Right.
say was that I want it to connect to my computer and control everything, right? I automatically assumed that was the base function. So if we talk about things like, Kano's matrix, we can talk about, the expected, the delighters, and sort of the need to have, the must haves,
The must haves. Yeah. Yeah.
um
Yeah. And some
sorry,
of
I'm
those
getting,
you can make assumptions about, right? Yeah.
yeah, absolutely.
Yeah.
So
And then the thing about the Apple mouse is that's unstated in everything you said, which is, the Apple thing, is that it's extremely elegant, right? And that may not be something a customer's going to say to you. I really want it to be aesthetically elegant. And then, well, what does that mean? How do we do that?
exactly, like that's those are probably the worst ones to have, because I can't put a measurement on that, right?
Yeah.
Or I can, but it's so subjective. In fact, one of the things that I work in the textile world a lot, and one of the things when you're gluing textiles together is that you want this quality called hand. It has to have a nice
Mm.
hand, or it has a bad hand.
So
Now,
that's how it feels.
that's how it feels. It's how it stretches. It's the weight. It's a lot of, very subjective measurements. And there are people that have made machines that sort of are supposed to give you some sort of mechanism of that. But one of the clever things that one of my employees did as she was testing these things out, and she decided to say, all right, well, let's do sort of, I want to rank these. I want to have some sort of quantitative data. So she made a bunch of samples, and they were looking for sort of like elasticity and just drape and these sorts of qualitative assessments. And she took it around to about 20 people and did a pairwise comparison on it, where she just brute force said, is A, or it's like the eye test, right?
Yeah, eye test. Yeah.
A or B, B or C or D, A or B, A or C, right? And what was brilliant about it is that, by having a decent amount of sample, right? You can't have infinite sample here. She was able to get some level of ranking of different types of properties, whether it's stretch, whether it's softness on these materials, on very qualitative measurements, right? So it was brilliant. It turned out amazingly well. I was skeptical on how concise the data would be, but there were a couple things that really were like, these are the things that this corresponds to.
So it sounds to me what you're saying is that there's sort of an intermediate step between the I and the D, which is if you're going to design to a customer need or desire, or design to quality, you have to have enough information to know, how am I going to measure that? How am I going to
Yep.
and if I can't measure it, how am I going to evaluate that? So it's like it's a designing a test for the test, which is really interesting, because that was, when the Wright brothers were building their aircraft, that was one of the things they had to do. Was some of the things that they needed to measure, there was no actual way to measure them, so they had to design the instrument to measure before they could actually design to that to their need as customers who did not want to die on their first test flight. So
Yeah, and that's actually a large part of doing application, new applications, is how do I test this to give a relevant result? Every material has sort of a standard set of data that comes with it, a set of properties, and those don't always immediately translate to the application that they want to be used on.
yeah, so yeah, there might be a way to measure something that's like it, but it's not exactly right. So
Yep.
you have to
Yeah.
build a new tool first. Wow. So okay, so you have identify, you have design, and then O is optimize. Is that what?
O is indeed optimize.
So
And
tell us about that.
so optimized is the one where we start doing a lot of experiments, right? So in the case of the mouse, right? This is where we're starting to link things like lightweight, I want it to be lightweight. Well, what does that mean? Well, it means sort of the sum of the components that you put into it. What are the heaviest components? What are the lightest components? And how do those affect in terms of, say, like a glue, right? I spent a lot of time with glue. It probably explains a lot about me, but the parameters around like hot melt adhesives, where you use heat to actually glue it together. It's time, temperature, and pressure. Those are the three factors every single time. And they're dependent on the type of glue. They're dependent on the type of substrate that you're gluing together. And optimize is it, this is a great one for optimize, because you can kind of keep the pressure the same. You can take that variable out sometimes you got to throw it in, but time and temperature, they're both nonlinear functions. With anything that I do is pretty much nonlinear. So using a nonlinear approach, you can get what is equivalent to like a topographic map of your process, right?
So not a two-dimensional limit curve, but actually something that has more of a three-dimensional component to it.
Yeah, absolutely. You can. What I love to see is, because if you know what you're doing, and you've done enough experiments to kind of put the parameters correctly, your sweet spot's going to be sort of right in the middle of your little graph there. Unfortunately, if you're charting unknown territory, sometimes you have to kind of do some guardrail experiments to figure out, where do I actually sit in this space? Because I've done experiments where it's like, oh, your properties get better up to this very point where you maximize both of your experiments. And I go, okay, well, I got to do another experiment
to find out where it falls off.
Around.
Yeah.
Absolutely.
Yeah. Yeah. So is this something now that you're using, that you're starting to use, some of these advanced data sciences and AI with, or are you doing it?
So, I think these are absolutely great tools for this. And this is how I start to teach, my classes. I'm like, look, this is sort of like level 1 machine learning, right? It is, you're building a mathematical model to represent these things. And we're using linear terms. We might use a couple nonlinear terms. But the important part is the interactions. When you start to get into large data repositories, that's when you can start using some of these more advanced models. I'm just starting to kind of figure out what best to do. It can be difficult. There's a few companies out there that are doing some of these things, where they will actually use machine learning. They'll help you formulate something, right? You've got a complex formulation. You've got 5, 10, sometimes 15 components going in all at once, and they don't know where you're at. So you might have sort of a starting formulation. You get that, and they'll give you sort of like, all right, here's the space around that. Do these experiments, and then it starts to fill in the gaps, and then they'll give you some more, as
So giving guidance as to future experiments to run, as opposed to saying you don't need to do this particular experiment because we've extrapolated, because they're based on, again, it perhaps leads to a type of false certainty, right? Well, the machine said it's going to work. Well, actually, and that takes us to the next step, right? Which is to
validate.
Validate.
IDOV, identify, design, optimize, and validate. And validate is the most important one. And in fact, I joke with my colleagues at Air Academy, because when I was working on my green belt, I was kind of like Luke Skywalker. I did everything, and I had my project all put together, and my coach said, all right, well, did you do a validation run? You have your model. Did you do a validation run? And I go, no. He's like, do you know that your model is correct? Right. Does it confirm? And I joke about the Luke Skywalker thing because I didn't finish my Jedi training, right? I
Mm.
had all the powers of a Jedi, the designed experiment, the customer feedback, the decision-making process, but because I didn't do the validation, I didn't actually finish my Jedi training. I eventually did, and they all patted me on the back and joked with me, and welcomed me into the crew. But it's something that I tell all my students now is like, don't be like me. You're gonna feel like you actually do this, but whenever you do an experiment, save an extra run for a confirmation run, because you have to do it.
Yeah, and where I come from, which is biology, um, there's so many variables, right? And one experiment's not enough. 10 experiments may not be enough. There is a point where you start to really to understand, but it's not as simple as, again, it's about certainty. It's like, well, I'm pretty sure I got everything right, but you don't.
Well,
Until
and
you get it out there, you really don't know.
absolutely, and I think 2 points to that. Number one is I was having dinner with some people last night, and we were starting to talk about creating products, and how does it actually having multiple avenues to confirm something is awesome. And I said, look, for me, if I can do it, that's one confirmation. That's great. If a customer can use my widget with my help, that's a great confirmation. But really, the end all be all is if a customer can use my widget without me being there, then I
Mm-hmm.
know I've got a bulletproof product.
Yeah, right. Yeah, because, and then actually, again, when you go back to cost for a company, that really reduces cost, right? If you don't have to spend as much time on customer support or manufacturing support either, but if you
Yep.
think of the plant as being a customer as well, if you're not spending that time and money on doing those things, I'm not saying don't support your customers, but
Yep.
then then you have more time and money to do R&D and develop new products and be more innovative.
Yep.
Uh,
and
yeah.
and that's really the hard part, is that people are looking at it as an extra cost up front, because you have to do
Mhm.
the work up front to get the benefit out the backside. And that's why DFSS was really implemented by all of our predecessors, because they saw that existing processes can only get optimized so much. DFSS really tries to squeeze the variability before it comes out the door, and that does take time and it does take money. But I have seen that it's much more effective on the back end.
Yeah, the better it is when it goes into the plant, the better it is when it goes into the hands of the customer. Again,
Absolutely.
the more it frees up time and resources to do other things. Yeah.
Yep.
I just want to talk a little bit about sort of a comparison with lean product development. And one thing that we haven't talked about yet is so the timing of the most critical experiment. So one of the things that we say in lean product development is, once you have identified, what it is that you want to make, what it is that you want to build that might meet the customer needs, um, there's value to ranking the questions that you ask. So some of the things that you don't know in order to accomplish the product are going to be things that are easy to answer, or if you don't answer them well, may not have a huge impact on the product or the sales of the product, but others are going to be critical. And so one of the things that is emphasized in lean product development is to do the experiments on the critical questions as early as you possibly can. Sometimes you have to learn some other things before you could do those experiments, with the idea that you don't take anything into late development that has critical questions unanswered, because stage gate processes and executives will always want to be pulling things through stage gates, in order to meet, what they told Wall Street, or what they told
Yep.
the customer about when something would be due. would be done, right? So, and that's how we get products that fail in late stage development or fail on the market, because we either didn't identify those critical questions or we didn't answer them early in the process. And so, as you're doing design of experiments, how do you think about that, and how do you decide which ones to do when?
Oh, absolutely. And one of the I'll give you an example. I'll give you my philosophy first, and then I'll give you a quick example. My philosophy on this is to force your system to fail on the smallest scale possible, right? If I can do a quick failure analysis on a computer, it costs very little money to design the widget, to run the FEA, and sort of say, oh, it's going to break here, right? I have just saved some time on that iterative loop. Anytime that a product has to go out to a customer, you're increasing the length of that feedback loop. So you've got to be able to figure out, how can I approximate what the customer is doing in the quickest way possible internally, because any sort of transaction, that's where failures happen. That's where time gets expended. That's where money is spent. But basically, if I can't make it fail on this scale, then we can move to the bigger scale and start the next step and try and make it fail, right? Like I often sort of joke that, when people meet me at a dinner party or something, I say, oh, what do you do? Oh, I'm a professional failure, because a lot of what I do is trying to make things fail early so I can discard them.
Right.
The example of that is I'm working with a colleague on a debondable glue, right? The purpose of this is so that you can have a durable product over its lifetime, and then at the end of its lifetime, you can pull it apart, right? Our phones, our tablets, a lot of our computers, they're held together by glue, and it's probably the least valuable part of the product. But if we can sort of get rid of, if we can make the glue debond at the end of its lifetime, we can pull out some of the more valuable parts of it.
For recycling.
And so for recycling, exactly. And so what we said up front is like, look, we have an idea that this is going to debond, right? We have an idea that it'll work. We did it sort of like on a very small scale, and we said, okay, this glues some stuff together, kinda, and it debonds. We're going to deal with that later, because nobody's going to care about the debonding if I can't stick something together in the first place. So we really set the development part really closely on the gluing part together. And now we're starting to work on the debonding, because we've got our critical value for our customers. And then, now we're like, okay, how much do we need to add to make this fall apart?
Right. Because you don't want the product falling apart
No.
after a year, right?
Yep.
Right. It's got to stick right away. Wow. Good stuff. Kris, how can people find you?
People can find me at geisysventures.com. It's GEISYS ventures.com. I also work on design for Six Sigma training and data analysis and coaching with Air Academy Associates. It's AIRACAD.com. And I'm on LinkedIn.
Great. And it's Kris with a K.
It is Kris with a K. That's a good point.
Yeah.
K and 2 Fs if you're looking for my full name.
There you go. Kris, what's your one piece of advice for a young person starting out?
I think the best piece of advice I can give people is to stay curious and don't try to show off your knowledge, right? Like, don't make those assumptions that we all make and just say, all right, what are we assuming here, right? Because it's the unspoken things that will get you.
Wow. That's great. And it's so consistent with what we've been talking about today. Kris Stokes, thank you so much for traveling with me to the edges of lean.
Awesome. Thank you for inviting me, and appreciate the conversation. It helps me think about things and just enjoy meeting new people.
This is Bella Engelbach, and I'd like to thank Kris Stokes for being my guest at the Edges of Lean. What did you learn from this conversation? What ideas did it spark? We would love to hear from you. You can find Kris at geisesventures.com or at airacad.com or on LinkedIn. Find me on LinkedIn or at leanforhumans.com or comment wherever you watch or listen. And check out my friends in the Lean Communicators community at leancommunicators.com, where you will find lots of great new content every week. The Edges of Lean is written and produced by Bella Engelbach with support from Podcast Inc. This is a Lean for Humans production.